Okay, so again, in the last example we were looking at, I had two VLANs configured on the different switches, where there was VLAN 100 that was on the ports of switch 1 connecting to the Windows machine and to router 1. This was also assigned on switch 2's port that's connecting to router 4. And then we had a second VLAN that was 101, assigned to the port connected to router 2, to router 5, and to router 3. Now, since the traffic is going between multiple physical switches in the network, we need to make sure that when switch 1 is receiving a frame in from router 3, it needs to tell the other switches, when I receive this packet, that you need to look in the MAC address table that is specific to VLAN 101 in order to figure out where that destination should go, or what particular local port that the packet is going to go out. And the way that they do this is that on the links between the switches, we're going to encode the VLAN number in what we call our trunking encapsulation. So again, the idea behind the VLAN trunks is that we want the VLANs to span between multiple physical switches. And to do this, we need to tell the switches what is the particular number that that frame belongs to. Specifically, the way that we do this is with a new extension to the Ethernet header that works with one of two protocols, the first of which is called Inter-Switch Link, or ISL, where this is a Cisco proprietary implementation or a Cisco-specific implementation. The open standard version of this one is IEEE's 802.1q, or what's simply sometimes known as .1q. The second one, the .1q, since this is the open standard, this is by far the more common implementation, because if I have a Cisco switch on one side and I go to an HP switch, as long as both of them run the .1q standard, then they're going to be able to understand the frame formats. You'll see that in a lot of newer versions of Cisco switches, they don't implement ISL anymore because everyone is moving towards the new open standard. Originally, when they first came out, there were some features that were only in ISL and not .1q, but it's not the case anymore. They're basically doing exactly the same thing, except behind the scenes they're using different formats for the actual data encoding. But the key is that the main thing that they're adding is what is the VLAN number when we're sending the traffic across the link. Now, we saw in the current configuration that the switches actually figured out that these links should have been running in trunking mode automatically. And we saw that when we looked at the show interface trunk, that on switch 1 it says that this interface that was going to switch 2 was a trunk. We could see this if we look at the show interfaces status. And it says for the VLAN number, this is a VLAN trunk, so it can carry more than one number at the same time. We can also see this when we look at the show interfaces trunk. This is going to show the individual options about the trunk links that are currently configured. Right now, for these four interfaces, which are the links that go between the multiple switches. So on switch 1, I have 4 links. 2 of them that go over to switch 2, 2 of them that go over to switch 3. It says that for these interfaces, they're running the encapsulation of ISL. So this particular version is going to try to run ISL automatically because these interfaces run in what's known as dynamic desirable mode. Now, you'll see, depending on the individual switch platform and the version of code that it runs, sometimes there's different default values for how these ports are going to behave automatically. But for this particular release of the Catalyst 3550, it's going to try to automatically figure out which ports should be trunks and which ones should not. And the way that it does this is by running a protocol that is VTP. It's the Dynamic Trunking Protocol. That essentially on these 4 interfaces, it's advertising itself to the other switches, saying that I want to prefer this interface to run the ISL encapsulation, which is going to allow me to advertise what are the VLAN numbers that I have assigned. Or excuse me, not necessarily the VLAN numbers I have assigned, but the VLAN numbers of the data that I'm sending out the interface. We also see here that it says that these VLANs 1, 100, and 101, these are in what's known as the spanning tree forwarding state. We're going to talk about this a little bit later today, but this is how the switches will automatically prevent loops of a packet going out one interface and then not coming back in another one. We can also see this when we look at the show interface switch port. Now this command is going to show you a lot of detail about what is the current status of the interface. Here it says that the interface is running as a switch port, which means that it's a layer 2 Ethernet interface. So this is where we would assign like a VLAN, an access VLAN. There's other cases where the switch can turn this into a layer 3 routed port. We'll talk about that more later when we get into to layer 3 routing. But normally the switch is going to run these as layer 2 switch ports. The administrative mode is what the interface is configured to run by default. So it's a dynamic port and it's in desirable mode, which means that it's going to try to automatically negotiate this as a trunk. The result of that negotiation is what the operational mode is. So it says, I tried to run trunking on this interface, but whoever's on the other side of the link, they're not trying to run trunking too. So the result is that it didn't become a trunk. It became an access port. This is what then I assigned the number by saying switch port access VLAN 100 on this port. But if we look at the interfaces that are connecting between the switches, on switch 1 this is 13, 14, 16, and 17. If I were to show interface fast Ethernet 0/13 switch port, it says this mode as well is dynamic mode. Desirable means that I'm going to send the requests out the interface, telling the device on the other end, I want to form a trunk. If they are also running this protocol, which is VTP, then we can negotiate this to a trunk, and we're also going to agree on what the encapsulation is. So is it either ISL or is it 802.1q? Where this particular version, the dynamic trunking protocol is going to prefer ISL, but we can configure it to do it however we want. So even though I didn't change any of the configuration here, if we look at the show run interface, fast Ethernet 0/13, it essentially has just default config. This command was there automatically, switch port mode, dynamic desirable. But since on the other side, on switch 2's port fast Ethernet 13, I essentially have the same thing. If we show interface fast Ethernet 0/13 switch port, this one likewise says I'm running in dynamic mode, and I'm running in desirable mode, which means I'm sending the requests out that interface. Since both of them agree on this, they then automatically form a trunk link. Now, Jeremy asked the question earlier, on the trunk links between the switches, what type of traffic will they actually send? You can see that by default it says that I'll send all VLANs. So you can configure the switch to limit what numbers you want to send on the interface, but by default, whatever ones that you create, it's going to send out those links. So as long as the switches agree on what the numbers are, they're automatically going to exchange those, the data for those VLANs. If we wanted to change the configuration to use a different type of encapsulation, or to not run in this dynamic mode, this would be at the interface level. So we'll go to interface fast Ethernet 0/13, and the vast majority of these options are going to be under the switch port command, because these are attributes of an interface that's running as a layer 2 switch port. We'll look at later cases where we say no switch port and turn this off. This is if I wanted to configure this as a layer 3 routing interface. So normally when the interface is in switch port mode, it doesn't have an IP address on it because it runs only Ethernet. If I said no switch port, then I could put an IP address on it and it would look like a router's interface. But here under switch port, we have the switch port mode, which controls, am I going to be one single VLAN assignment, which is an access port? Do I have multiple VLANs, which is a trunk? Or do I automatically decide between the two of them, which is dynamic mode? For this particular platform, it runs dynamic mode automatically. So it figures out, should I be access or should I be trunk? We can also set what are the switch port trunk options. The encapsulation would control, am I running ISL or am I running .1Q, or am I going to try to automatically figure it out? So the default for this platform is that the switch port mode is dynamic, and the switch port trunk encapsulation is going to be negotiated. So essentially, they both figure out that they want to run ISL trunking. But if I were to say that the encapsulation should be .1Q instead, on the other side, on switch 1, if we look at the show interfaces trunk, I would see on that one individual link, I now have negotiated to run .1Q encapsulation as opposed to ISL encapsulation. Where again, they're pretty much going to accomplish the same thing, where the key is that when we send frames out the link, we're going to add what is the VLAN number. So not only are we going to have, let's say we have a web browsing packet that's going from A to B. When it gets to the layer 2 switch, we may have our web packet that's inside of the application layer. Then at layer 4, this runs over TCP. At layer 3, this runs over IP. At layer 2, this is running over Ethernet. But then inside of here, we're going to have a field that says what VLAN does it belong to. This is then part of either the .1Q header or the ISL header. Sometimes you'll hear that ISL is considered an encapsulation, where .1Q is considered a header, because technically ISL also adds something at the end, where this is considered the trailer, the end of the frame. This is the header, the front of the frame. So this one takes more bytes to actually encode the data, which means it has a higher encapsulation overhead, we call. So it's just more data that it has to send in order to exchange the same information. .1Q is a little bit more efficient with its communication. But again, the end result is going to be the same, that we exchange what are the VLAN numbers. You would also see that this type of encapsulation, whether we are running ISL or whether we are running .1Q, as long as the directly connected devices agree on this, it's only locally significant between the two of them. So you can have cases where some of the network runs ISL, some of the network runs .1Q. It's not going to matter, because when the switch receives the frame, it's going to be removing that portion of the encapsulation. So if router 1 is in VLAN 100, when the IP packet goes out this way, router 2 is saying that the IP source, let's say that the packet's going to router 4. So router 1 is going to say that the IP source address is my address, 192.168.0.1. The IP destination address is router 4, 192.168.0.4. It then needs to tell the switch what? Because the switch isn't looking at the IP addresses in the packet. It's looking at what? It's looking at the MAC addresses. So it needs to say, what's the MAC source address? This would be whatever router 1's MAC address is. The MAC destination is going to be whatever router 4's MAC address is. So this is how router 1 generates the frame. When it gets to the switch needs to send it over this link and then also add that trunking header. So with the additional trunking encapsulation, we then say that the VLAN is 100. When switch 2 receives this, it's going to take this portion off. If it needs to continue on, it's going to add its own new additional trunking header, but it goes on a device-by-device basis or on a hop-by-hop basis. So again, you can technically have ISL over here and .1Q over here. There's not going to be any negative result of this. Most of the time, the network would standardize on one versus the other, just for simplicity. Okay, so let's look at the final configuration of this. What I want the network to look like when I'm done is for the frames coming in from VLAN 100 to go out this Fast Ethernet 13 that goes over to switch 2. Then for frames that come in from 101, they need to go from switch 1 down to switch 2. Switch 2 needs to send them over to switch 3. And switch 3 is going to send it out this direction to router 5. What I'm also going to do here to simplify the network a little bit is disable some of the other interfaces that we're not using. So on switch 1, I'm going to disable these 3 interfaces. And I could do that with what command? If I want to basically turn them off, is the shutdown command. Shutdown. And a little bit later today, I'm going to explain in more detail why I want to disable these interfaces. Then on switch 2, I'm going to shut down that port here, this 17. If we look at the end result of this now, when switch 1 says show interfaces trunk, I need to make sure that Fast Ethernet 13 is running either .1Q or ISL. I don't really care which one it is, but also that VLANs 100 and 101 are agreed upon. So switch 1 agrees on that. Switch 2 should say the same thing. If we show interfaces trunk, says one of the interfaces, Fast Ethernet 13, I set this to run at .1Q. The other one I left it as the default, which it negotiated ISL. If I show run interface Fast Ethernet 0/13 and compare this with the config on Fast Ethernet 16, the defaults here are going to try to use ISL. This one I told it manually it should use the different encapsulation. But the end result is going to be the same. If we were to go to router 3 and send the traffic to 5, we see that they have layer 3 IP communication. If we look at the show ARP, I know what is my IP address and my MAC address. I also know what is router 5's IP address and router 5's MAC address. So these two values here, if we were to look at them on switch 2, what is switch 2 going to say about those MAC addresses? It should say for this one, it knows about it on what interface. To get to router 3, I should use Fast Ethernet 0/13. To get to router 5, I should be using Fast Ethernet 0/16. So as long as we're running trunking on both of the links, ultimately switch 2 is going to know about the MAC addresses for all of the hosts in all VLANs. And that's what's allowing us to span the VLANs between the multiple physical switches. That essentially the switches always keep track of everyone's MAC address in the network. So if I show MAC address table, the dynamic MAC addresses for VLAN 101, it says I have this address here, the DA80, this is on Fast Ethernet 13. That's going towards router 3. Then the other one, this 0861, this is the one that's corresponding to router 5. It knows that this is reachable on Fast Ethernet 16. Now, if you were to remove the trunking encapsulation, if I were to set this as a normal VLAN 1 interface, then you'd find that router 3 and 5, they wouldn't be able to communicate with each other. Because switch 1, when this is coming in VLAN 101, I need to make sure that on the other end it knows that it's supposed to be in part of that virtual LAN. Now, we also saw before when I created the VLAN numbers and I gave them names, that the switches actually automatically agreed upon this. And the reason why is that by default, they run an additional protocol that is the VLAN trunking protocol, or VTP, where the idea of this is that it's going to simplify some of the management for us in the network. That if on one of the switches I define what are all the VLAN numbers and what are the names for them, I can automatically advertise this to the other switches, and then they can choose to either assign the VLANs or just ignore them, but I only have to create them in one individual place. So as long as I have the trunks that are going between the switches, they're automatically going to learn the names and the numbers. The key for this, though, is that it's not really a requirement of Ethernet. It's just one of the added features that the Cisco switches have. So for this protocol, we can see its options when we look at the show VTP for the VLAN trunking protocol, show VTP status. So in the VLAN trunking protocol, it's a client and server-based protocol where the server is going to be the one who creates the VLAN numbers, assigns them names, and then advertises it to the other devices. Where the switches, by default, whenever they hear a VTP domain name, which is kind of like your Windows domain name, it's just a grouping of administration, devices who share the same domain name should have the same VLAN numbers and the VLAN names. So if I were to say that my VTP domain is CCNA, and the other switches agree on this, that the VTP domain is CCNA, then as long as I'm running one of the trunking protocols, either ISL or .1Q, and I somehow have end-to-end connectivity between the switches, so on a hop-by-hop basis, there's trunks in the network, I should be able to make VLAN changes on just one of them, like create VLAN 102 and give this a name of support. And VLAN 103, name is meeting room. When we now look at the other switches and show VLAN, we should see that they're automatically going to learn these. Now notice it doesn't control what ports you actually assign the VLANs to. I would still need to take the next step and go to the link and say switchboard access VLAN 102 or switchboard access VLAN 103. But the idea is that it makes it a little bit easier to get the switches to agree on what VLAN numbers you should use. So there are some additional features that go along with this. If you look at VTP and then issue the question mark, you'll see, like for security, if you were to use this, you would want to put a password on the domain to make sure that if someone makes a change, it's not going to be received by the other switches unless they agree on the authentication password. The VTP mode, this would be, am I the server who is creating the changes? Am I the client who is just listening? Or am I running in what's known as transparent mode, which basically means I'm going to ignore everyone else's updates. So if you don't want to run a VTP, you would set the mode to be transparent. So now with those new two VLANs that I created, 102 and 103, if we look at the show interfaces trunk, we should see now that these are added automatically to those links that are running either ISL or .1Q. So anytime a new assignment comes in, if I connect a host and assign them to VLAN 103, as long as the devices on the other side agree on that same VLAN number, then I should have communication end-to-end between the hosts. You'll also see for these switches that by default, the VLAN numbers, this information is not stored in the running config. So if you look at the show run output, you're not going to see anything about the VLAN numbers or the VLAN names. It's actually stored in a file on the flash that is the VLAN database, or the VLAN.dat. So what this means then is that when you back up the switch's config, not only would you want to copy off the running config, you would also want to make a backup of the VLAN database. So copy this to your TFTP server or your FTP server so that if for some reason this information changes, you could always revert back to the old one. The other option here is that if you were running in VTP mode transparent, again, what this means is that you just ignore everyone else's VTP updates. So you're basically not running the protocol with anybody else. When the switch is running in VTP transparent mode, its VLAN information is now local. So now the VLAN's names and the numbers do show up. So if I were to make changes, if I said for VLAN 103, this name is not the meeting room, or if I were to add another VLAN, when I look at the other switches and show VLAN, they're not going to receive these new updates. Because a switch that is running in VTP mode transparent, it's basically not exchanging this information with the other switches. But it's kind of a key point here because the switches run this automatically. That if you don't turn off VTP, someone else could potentially delete the VLANs that you're using. So if I go to switch 2, and actually before we do this, let's do this. Before I delete the VLAN, let's go to the Windows machine. And I'm going to ping one of the other devices that it's in its same VLAN, which is like router 4. This -T option, this means just to keep running the ping over and over. If I were now to go to one of the other VTP servers and delete the VLAN, no VLAN 100, now you can see they can't reach each other anymore. So this is kind of the shortcoming of running VTP, that if you make a configuration error anywhere in your VTP domain, you could potentially start dropping traffic between the devices. So in a lot of real designs, this protocol is convenient, but it's kind of a security risk at the same time. So unless your switching network is huge, where you have thousands of VLANs that you need to keep track of the names and the numbers, probably you're better off just doing the configuration manually over and over. That you would set the switch to transparent mode, which means if someone makes a change, it's not going to affect this local switch. But as long as I add this VLAN back, switch 2 should start advertising this through VTP, and then eventually we'll see that the Windows machine should regain connectivity. Should take about 30 to 45 seconds here. Which it does now. This delay, we'll talk about this a little bit later, why it didn't happen immediately. Okay, any questions on the trunking with ISL and .1Q or the VLAN trunking protocol, VTP? So the difference is that this is just for management. It doesn't actually control what the broadcast domains are. It's the VLAN numbers that control those. As long as the switches agree what the VLAN numbers are, the host should be able to talk to each other when they're in those same VLAN numbers. This is just to make sure that the switches have the same names and the same numbers advertised.